Hey everybody. Okay, let me move this out of the way. I hope you can hear me. Let's see. I have to bring these, let me bring these into view so we can read about them, explore the documentation, and build something with these. Okay, so the real-time API seems to be the most exciting. The OpenAI the docs are updated as well. Right here, real-time API, fine-tuning, also have vision fine-tuning, evaluations, distillation, which we'll read about. Okay, so let's begin. Let me know if you have any issues with audio. Okay, audio is good. So let's begin with, of course, real-time API. We can start reading here. Today we're launching how it works. I guess you can browse these on your own, I suppose. Let me put the link in chat if you want to take a look at it. And real-time API. Okay, let's just start with directly with documentation. Let's build something. Real-time API enables you to build low latency multimodal conversations, native speech-to-speech, natural steerable voices, simultaneous multimodal output. Quick start. There's a console. It says, is it live? Oh, okay, there's an example repo we can take a look at. It's also open the playground. I don't think the playground is updated, at least not for me. So let's go back to this. Quick start. Real-time is a WebSocket interface. That's nice because WebRTC always seemed a bit confusing to me. I understand WebSockets better. What account level? I'm not sure. I think everybody gets access to it. Maybe as we read more, um, we'll find out. Real time to help you get started quickly. We created a console demo application overview. Real time API is stateful event-based API that communicates over a WebSocket. The WebSocket connection requires the following parameters. Query parameter. Let's also look at the models list. Model list is probably updated as well, probably. GPT-4o. Okay, can't tell from here. Authorization below is a simple example using the popular WebSockets library in Node.js to establish a WebSocket connection, send a message from client. Oh, okay. So there's no Python example, I wonder. It says JavaScript only. Okay. Sessions. Well, that's a bit of a bummer that they don't have Python. Input audio buffer. So let's take a look at this then. Um, OpenAI real-time console. We'd have to clone this, copy the code, create a new project, OpenAI advanced voice. Yeah, Playground is not updated yet, but we can definitely test this out. We have to open the terminal and call git clone and paste paste the example repo. And here we have it. We have to go into the OpenAI real-time console, and then let's follow the instructions. 1 second. Oh, we don't need this. Go back to here. Oh no. Okay, as we just need to install npmi to install all the packages, and then npm start, and then we can read about it. npm I will install npm I will install everything in the package.json, kind of like requirements.txt, installing that. Then we're going to say npm start should be available, and then we'll read more about it. This is very exciting. So they also announced prompt caching. It's all done automatically. Uh, Maybe they have an example here somewhere. Cache, prompt caching. Yeah, it's all done automatically, so you don't have to set. While reducing number of input tokens does result in lower latency, cutting 50% result in. So every prompt, every token that from what I read, every token that it sees, it automatically reduces the cost by 50%. So you don't have to set anything up or write special, API call parameters or anything like that. Okay, let's start this. There we go. It's loading, and these are all the pages. Localhost. Oh, it's asking for API key. Let me grab it from my environment variables real quick. Grab that. Oh, I wish they had locked it up. I'll have to delete this key, but we can use it for now. Events awaiting connection. Okay, manual. Let's connect. Let's try manual first. Oh no, we got our first error. What happened? Let's use VAD. Connect. Not connect. Oh, yes, cannot connect because, yeah, why not? We have, it says here, should have OpenAI libraries updated package. I'm pretty sure. Maybe it doesn't. Let's do this because it's not able to. Yeah, I'm going to. I'm go. It's uh, it's probably doesn't. I don't see the OpenAI package here, and you have to update your package with an API update. So let's say npm install latest OpenAI. Let's run this. Be able to see this in node modules. Okay, let's start this again. npm start. Okay, connect. Cannot connect. Is it not fully live yet? Possibly. Let's ask the let's ask it in chat using the code base. But it seems to me that it just cannot connect to this endpoint. Establish your OpenAI, but it's failing. Network issues. API key authentication. That's not the issue, I don't think. I don't think so. Hmm, that's interesting. You know what? I mean, did you guys try this? I mean, it's just not being able to connect. I wish there was a quick, easy Python way of checking this. Let's go back to the docs again. Real-time API. Maybe we can just try this real quick. If But we'd have to initialize a Node.js project now. Fresh, connect. Hmm. Maybe it's not fully live yet. Maybe we'll come back to this then. Let's try this. Let's take a look at this other stuff real quick. Prompt caching. Many developers use the same context repeatedly across multiple API calls when building AI applications, like when making edits to a code base or having long multi-turn conversations with a chatbot. Today, we're introducing prompt caching, allowing developers to reduce costs by reusing recently input tokens, getting 50% discount and faster prompt processing times. So starting today, prompt caching is automatically applied on the latest versions of GPT-4o. It's automatically applied. That's the beautiful part of it. So uh, it's just going to automatically cache your input tokens and reduce the cost by half. Can monitor cache using. Let's go to prompt caching docs. Smaller prompts often contain repetitive content, making it cheaper, faster. This can reduce latency and post up to 50%. Also, that was the case with Anthropic as well. And prompt caching works automatically on all your API requests. No code changes required. Yeah, that's the beautiful part. Enabled for all the latest models. Yeah, see, kind of like that. So original prompt and cache hits are only possible for exact prefix matches within a prompt. To realize caching benefits, place static content like instructions and examples at the beginning of your prompt and put variable content such as user-specific information at the end. This also applies to images and tools, which must be identical. So you can even apply caching on images. See, this original prompt is the screen part. But if you were to add something to the beginning of it, then it's gonna miss the cache. So you put the stuff in the beginning, whatever is in the beginning is cached as long as it is 1024 tokens or longer. When you make an API request, the following steps occur. Cache lookup, the system checks initial portion. If a matching prefix is found, the system uses cache result. This significantly decreases latency. Okay, so essentially, we can view this. Right, so all we need to do is just make a call. We can definitely test this. Test.py. Let's grab just a regular call to chat, text generation. Let's just call GPT-4o. And we just need to put this is the JavaScript. We just need to put a long prompt in. That's all. So, I mean, system message. Maybe we can just do this. As a matter of fact, maybe we can go to distillation and copy all this. Let's just create a little docs.txt file and put all this stuff, the new stuff in there, and we'll pass this as our fine tuning, vision fine tuning. So we'll create a context out of these and then ask questions about it. We pass it in the system message. Also real time distillation. We got that evaluations, and then let's grab the real time API. Put this in. Let's grab all this by Control C and go to OpenAI tokenizer. See how many tokens this is going to be. 13,000 tokens. So this should be cached. Let's go back here and open. So let's just say open docs, read docs.txt and pass it in system message instructing the model to answer questions with that context in mind. Okay, let's do that. And we are just going to print the completion just to see. Let's break out of this and remove this. We're just going to look at the completion to see how we can see if it's cached or not. Also, let's just quickly see. So then we can do something else with it. Encoding, encoding UTF-8. I also have to pip install OpenAI dash upgrade. To get the latest version. Okay, see, right here, completion tokens, total tokens. How does it say we're supposed to see it? Prompt caching. In the usage field in the API response. Usage, total tokens. Right, it doesn't display that because we have to hit it twice, right? So it's not going to display any cache. So therefore, we need to make this multi-turn, make this an interactive chat by taking user input, keep track of the convo history in messages. Okay, content. Let's print completion as well. I think we need to do usage is under, it's going to be instead of message, I believe, choices, content. Let's just print it and see. Each time, going to print it. Let's just say hi. Total tokens, chat completion object. Okay. Oh, yeah, this is that content. It's not a dictionary. Okay, we get the first response. There's no cache. Let's say hi again. Usage. Oh, I didn't see cache. Why not? Well, this is 2 out of 2. That's not working. Let's see. Let's go back and see if we're missing something. Prompt caching docs. Yeah, it should say prompt tokens, completion total tokens, prompt token details, cache tokens. It should display that. We are creating a messages list with the docs content and continually appending to it. So we are sending the same messages. Let's try this again. Let's say hi. So you should display right here, prompt token, total tokens, 13,000. So we are sending the same tokens, cache tokens 0. And it was, okay, I just saw it. Cache tokens 0. Why? Are we missing something? With cache hits occurring in increments of 120, therefore the number of cache tokens. All requests, including those with fewer than, will display a cache tokens field. What can be cached? Messages, images, tool, structured outputs, okay, but structured prompts, well, it should cache it. How can we print the cache here? Print only the cached tokens. Oh, we have to give it the example. Let's run this again. Hi, 0. Cache tokens is 0. Hi, how can we cache tokens? I don't think we put it into the docs about caching, but okay, it's going to give a long response. Doesn't seem it's working right now. Again, this one either. Okay, long response, but it's still 0, 0. It's not caching it. Didn't we update? Well, we did update the OpenAI library because we are able to get the cache tokens, and we are inserting the messages as like our first message is not changing at all, and we are just appending to it the message, user message, and when we get an assistance reply, we're appending to it. So this whole thing, the 13,000 tokens, should be cached, unless we're doing something wrong. But it says it's automatic. Prefix matches within a prompt. Please place static content like instructions examples in the beginning of your prompt and put variable content such as user specific information at the end. That's what we did. OpenAI cookbook. Let's see if they have examples here. No, they haven't updated it. But okay, well, I suppose this didn't really work. Unless you guys know why not, do let me know. Let me check if somebody said on Twitter if anything was said. I'm not sure, but I also bookmarked this that we have launched an open source repo real time console. Yeah, we did check that, didn't we? This didn't work either. Let's try that again, actually. Let's run our server, npm start. Oh, we have to get into the folder, connect. Did we not update it in the right folder? Did we not install the OpenAI in the right folder? Npm install latest OpenAI lib package. Okay, let's run this again. Yeah, could not connect. I mean, it just can't connect to the endpoint. And we did say OpenAI. Yeah, we do have the latest version here. We already installed it. I wonder if you guys tried it and get it working. So let's try to solve this caching issue one last time. Caching is available. What can be cached? Look, it says messages, the complete messages array encompassing system user assistant interactions. So that's exactly what we're doing here. We have the initial system message in the beginning. Does it take a moment for it to be cached? Structure prompt with static or repeated content in the beginning and dynamic content in the end. Monitor metrics such as cache hit rates, latency, and percentage of tokens cached to optimize. To increase cache hits, use longer prompts and make API requests during off-peak hours, as cache evictions are more frequent during peak times. Maybe it's busy right now. Prompts that haven't been used recently are automatically removed from the cache. Minimize evictions, maintain a consistent stream of requests within the same prompt prefix. Is there a way to manually clear the cache? Is not available. Prompt caching does not influence generation of output tokens. Cache prompts contribute to TPM, yes. Does prompt caching, okay. Let's test it again. Oh, break out of this. Oh, we gotta get out of this folder. Say hi. Okay, zero prompts cached. Again, zero tokens. Yeah, it's not catching it. Hmm. I'll have to look into it. As you can see, we are printing the cash tokens, but we are not seeing any results. Okay, what else do we have? Introduction to Vision through Fine-Tuning API. Says today we're introducing a vision fine-tuning on GPT-4o, making it possible to fine-tune with images in addition to text. Developers can customize the model to have stronger image understanding capabilities, which enables applications like enhanced visual search functionality, improved object detection for autonomous vehicles or smart cities, and more accurate medical image analysis. Interesting. Since we first introduced fine-tuning, okay, how it works. Vision fine-tuning follows a similar process to fine-tuning with text. Developer can prepare their image data sets. Okay. Yeah. So it's going to be, I'll make a separate video on this, but it's going to be similar to how we did previous fine tuning. You just create a messages list, probably in a JSON-L, grab image, improves images. So you can, here in this case, create a system message. You're an assistant that identifies uncommon cheeses. What is this cheese? Upload an image and then have an answer prepared. And you prepare a bunch of these and fine tune with that. Maybe let's read about this model distillation in the API. Let's see, find out what this is. Fine tune a cost efficient model with the outputs of a large frontier model all on the OpenAI platform. That's interesting. We are introducing a new model distillation offering to provide developers with an integrated workflow to manage the entire distillation pipeline directly within OpenAI platform. This lets developers easily use the outputs of frontier models like O1 Preview and GPT-4o to fine-tune and improve the performance of more cost-efficient models like GPT-4o Mini. Okay, this is going to be like teacher-student style distillation, I suppose. Model distillation involves fine-tuning smaller, cost-efficient models using outputs from more capable models, allowing them to match the performance of advanced models on specific tasks at much lower costs. Until now, distillation has been a multi-step error-prone process which required developers to manually orchestrate multiple operations across disconnected tools, from generating datasets to fine-tuning models and measuring performance improvements. Since distillation is inherently iterative, developers needed to repeatedly run each step, adding significant effort and complexity. Our new model distillation suite includes stored completions. Developers can now easily generate datasets for distillation by automatically capturing and storing the input-output pairs. Evals, developers can now create and run custom evaluations. That's great. Stored completions evals are fully integrated with our existing fine-tuning offering. How to use model distillation. First, create an evaluation to measure the performance of the model you want to distill into, which in this example will be GPT-4o Mini. This evaluation will be used to continuously test the distilled model's performance to help you decide whether to deploy it. So all of this should be available in the dashboard. Let's check that at least to see. So at least if Playground have changed. Haven't changed for me. I did a poll on this. Let's see what people are saying. So far nobody actually um, got it. I'm kind of bummed about this. Push to talk. Oh, disconnect. Oh, so we did connect. Oh no. Oh, we did connect. Did we? Let's try it again. Sorry, I'm jumping around, trying to explore everything. Okay. Oh, why? Connect. Well, why did we see? that one time it was connected. Oh no, it's not connected. Okay. It was just a look. Where were we? Model distillation. Yeah. So what currency is the exchange rate calculated in? So you have some preview test data, which I think is going to test against both the original model and the distilled model. Next, use stored completions to create a distillation data set of real-world examples using GPT-4o's output for the tasks on which you want to fine-tune GPT-4o Mini. You can do this by setting the store true flag in the chat completions API to automatically store these input-output pairs without any latency impact. These stored completions can be reviewed, filtered, tagged. Okay, I guess you can interact with, like, say, GPT-4o and then store each interaction, and then finally on your dashboard, you can just like this, you'll be able to actually change, like modify those distillations, which we should be able to see here. Evaluation, see if we had some, so they will appear here. Oh, so wait, this is updated then. Is it? No, no, I'm sorry. It's on the dashboard. Sorry. Evaluations are here. Okay. Great. So you create a test data, generate responses. So I guess this is really just like fine tuning, except they automated the process of generating the fine tuning data set. That's my understanding. So imagine you, we did this several times in several videos, but you would have to first generate the data set, then fine tune, and there was really no way to evaluate. Here, in this case, I think it auto evaluates itself, or at least it shows you evaluation, which then uh, you can use the evals to actually filter through your data set before fine tuning. So this is interesting then. So you create the data set, preview test data, and so you can add testing criterias, and then only estimate the cost and only then fine tune. I hope this is still included in the free fine-tuning. Finally, use this dataset to fine-tune GPT-4o Mini. Stored completions can be used as a training file when creating fine-tuned model. Once the model is fine-tuned, you can go back to evals to test whether the fine-tuned GPT-4o Mini model meets your performance criteria. So this is really interesting. We can test this, I guess. Let's grab this. We can test it exactly as is. Let's say distill.py. Import OpenAI, client OpenAI. So this should be stored now, including metadata, although we don't exactly need it. Close this. We run this. So we just ran it. Now we should be able to see it in our dashboard. Dashboard, evaluations, storage. Well, how do we view these? Create an evaluation measure. Next, use stored completions to create a distillation data set of real-world examples. These stored completions can be reviewed, filtered. Yes, I thought it was supposed to look like this, distillation test. Right? Import. Storage. So where are they stored? Thought I should be able to see it here. Let's refresh. I thought I should be able to see something like this. Create an evaluation. OpenAI provide built-in tools. OpenAI dashboard. I'm curious where it did store. So it said store this, but I'm not sure where this went. How to use model distillation. First, create an evaluation measure the performance of the model you want to distill into, which in this example will be GPT-4o Mini. So we need the test data. Hmm. Next, use stored completions to create a distillation data set of real-world examples. So you first could generate the data set and then use the model. Yeah. Next, use stored completions to create a distillation data set of real-world examples. Okay. You can do this by setting the store true flag in the chat completions API to automatically store these input-output pairs without any latency impact. But first, we need to create one. Create. Okay. This also requires an additional look. Let's go back and test this prompt caching one more time. Yeah, it's not, it doesn't display that it's caching it. Okay, so I'll have to look deeper into all of this, but this is it. The evaluations, distillation, prompt caching, and real-time API, none of which we were able to get running properly, but nevertheless, they're there, and we'll figure it out.